Welcome to the 2021 Top Discoveries in Radio Astronomy, made possible by the National Radio Astronomy Observatory. Radio astronomers can take images of the moon by bathing it with pulses of radio waves from radio telescopes, then detecting those pulses when they're bounced back to Earth to map the moon's surface. This is how radar works. The amount of detail they can see using a radio telescope depends in part on how big the dish is, called its aperture. A larger antenna means seeing smaller features. But you don't need to build such a big dish. During observations, both the Earth and the Moon are moving. If the radio wave pulses illuminate the Moon for a long enough time, the dish will have moved by its own length, essentially doubling its size. By carefully recording the reflected pulse arrival times, astronomers can use this to simulate a much larger dish, a technique called synthetic aperture radar. With the immense 100-meter Green Bank telescope and NRAO's Very Long Baseline Array, astronomers use this technique to observe the Apollo 15 landing site, seeing hills, craters, and rills, snaking channels carved by ancient flowing lava. They also looked at Tycho, a lunar crater over 50 miles across. They were able to see details as small as 16 feet wide, and the final image is 1.4 billion pixels in size. These results are so promising that NRAO received a $4.5 million grant from the National Science Foundation to expand the project. And that means bigger and even better images like these will soon be on their way back from the Moon.